children, today also we are going to continue NCERT solutions only. It is for the video is for 7th January. Exercise 1.3, question 1. Write the following decimal form and say what kind of decimal expansion each has. Question number 1, 36 by 100, 1 by 11, 4 integer 1 by 8, 3 by 13, 2 by 11, 329 by 400. Question number 1, we can see the solution. What is the question? 36 by 100. On divide by 36 by 100, we know that we are going to get a 0.36. It is very easy only because it's the decimal expansion by 100, 10 to the power only. So 0.36 means it is a terminating decimal. So it is asked that what is the decimal expansion, which kind it is. So our answer is it is terminating decimal. Second question, 1 by 11. On dividing 1 by 11, what we get? Let us see that. On dividing 1 by 11, we are getting the quotient as 0.0909, etc. That means what we can write? 1 by 11 equal to 0.090909, etc. This shows that 09 is the group is repeating there. So we can write that 0.09 bar. The bar is for 0 as well as 9 also, which is a non-terminating recurring decimal. Non-terminating recurring decimal. So what is the decimal expansion of for this question we are getting means non-terminating recurring decimal. 4 integer 1 by 8, that means 33 by 8 only. The number is 33 by 8, that means we have to divide 33 by 8 only. You can see the division here. What is the quotient we are getting there? 4.125. So I'll write here 33 by 8 equal to 4.125. That means which type of the decimal expansion we are having here? Terminating decimal. So this time this rational number is having the decimal expansion which is terminating 1. Next question is 3 by 13 only. You can see the division, that is 3. When we are going to divide with, you are getting the first remainder is 30, again 40, then 10, again 10, 9, then 12, then 3 is coming. That means when 3 is coming means it's the process is repeating from here onwards. So what is the answer when we are doing 3 divided by 13 means 0.230769. After this 9, again this group is repeating. So the bar is given for 2 to 9 only. So it is again what this shows that it is a non-terminating recurring decimal. So the decimal expansion for 3 by 13 is non-terminating recurring one. The next question is 2 by 11. Normal division only. If you are doing the division procedure, you will get the answer as 0.1818, etc. That is the quotient we are getting there. That means 2 by 11 equal to 0.1818, etc. The group 18 is repeating, that means 0.18. The bar is given for 1 and 8 only. This shows that the decimal expansion is non-terminating recurring. So the next question is 329 by 400. Again division only. There is no need of explaining how to do the division and all. I'll just go for the quotient only. 329 divided by 400. If we get do the division, we are going to get the quotient as 0.825. Anybody is having the division procedure doubt, they can see that left side it is given, and the question is asked which type of the decimal expansion. It's a terminating one, ending one only. That means it's a terminating decimal. Question number 2. You know that 1 by 7 equal to 0.142857 etc. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? We have to see the solution means what is 1 by 7 we should find out. 1 by 7 equal to 0.142857 only. The group is repeating again. That means 0.142857 bar. Again we have to find the value for 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. That means 2 by 7 means it is 2 into 1 by 7. 3 by 7 means it is 3 into 1 by 7. 4 by 7 means 4 into 1 by 7, and 5 by 7 means 5 into 1 by 7, and 6 into 1 by 7. So we can substitute the values for 1 by 7 as 0.142857 etc. and multiply with the respective numbers. 2 into 1 by 7 means 2 into value of the 1 by 7, that is 0.142857 etc. to be multiplied. We'll get the answer 0.285714. We can see how we are getting the multiplication. Normal multiplication I had done here, 0.142857 into 2. We are getting the 0.285714. But here also you can see some pattern it is repeating there. See that when we are doing the 1 by 7, you are getting 0.142857 only, but when you are going to multiply with the 2, we know that 14 2s are 28 only. So your pattern is starting from this 2857 then 14, right? Similarly 14 3s are 42 only, so your value is starting from this 4 then cyclic order, that is after 4 it is 2857 etc. I think now you got the idea how to get the multiplication and all. We will get the answers as 3 into 1 by 7, 4 into 1 by 7, then 5 into 1 by 7, 6 into 1 by 7 respectively. The answers are 0.428571 etc., 0.571428 etc., 0.714285 etc., 0.857142 etc. It can be written like this also, bar, using bar also, that is 2 by 7 equal to 0.285714. The bar is given to for all numbers, and again 3 by 7 when you are writing, the bar is given for from 4 to 1 only. That means 0.42857 bar. Again 4 by 7 we can write as 0.571428 bar, 5 by 7 0.714285 bar, 6 by 7 0.857142. Question number 3. Express the following in the form of P by Q, where P and Q are integers, Q not equal to 0. First question 0.6 bar, second question 0.47 bar, and 0.001 bar. That means the first question single digit only given, the second question 2 digits are given under the bar, and the third question 3 decimal part it is given under the bar only. Now we can see the solution. The question is the first one, x equal to 0.666 etc. We will put the equation as a 1. Then we are multiplying the next step by 10 on both the sides. So 10x equal to 6.666 etc. If we compare equation 1 and 2, after the decimal, the terms are same only. That is 6 is repeating. So subtracting 1 from 2, 2 from 1 we can do. Then we are doing 2 from 1 only. So subtracting 2 from 1, I'll write. Then what is that one? 10x 6.66 minus x equal to 0.66 etc. That means 9x equal to 6, x equal to 6 by 9, or x equal to 2 by 3. Therefore, 0.6 bar equal to 2 by 3, which is in P by Q form. So we got 0.6 bar, we have expressed in terms of a rational number. Question number 2, x equal to 0.477 etc. Then we are multiplying on both the side. Then we'll get a 10x equal to 4.77 etc. That is our equation number 1. Then 100x equal to 47.8777 etc. Put equation 1 and 2. What is the next step? 2 minus 1 we can do. Then 100x equal to 47.77 etc. 10x equal to 4.77. That means we can see that the decimal part is same. Now we have to do the subtraction. Then you will get a 90x is equal to 43 or x equal to 43 by 90, which is in the p by q form. Now the third question, let us see. X equal to 0.001 bar, x equal to 0.001001 etc. 10x is equal to 0, 1 0 we remove to left, so 0.01001 etc. Then 100x is equal to 0.1001001. Again 1000x equal to 1.0101 etc. Now when you compare the respective equation 2 and 1, we can see that the decimal part is same. So equation 2 minus 1, this time I have done for 1 minus 2 only. So 1 minus 2 equal to 1000x is equal to 1.001001 etc. x equal to 0.001001, that is 999 x equal to 1. That means x equal to 1 by 999, which is in the p by q form. So what I want to say that when it is given that decimal expansion, non-terminating and recurring one, we are able to express in the form p by q. So when the decimal expansions are terminating one as well as non-terminating recurring one are getting then the numbers are rational number, and we are able to express by this method in p by q form. Question number 4. Express 0.99 etc. in the form p by q. Are you surprised by your answer? Discuss why the answer makes sense with your teacher and the classmates. Now solution, how we can say, means the same procedure we should do. Let x equal to 0.99 etc. and we need to multiply the 10 on both the sides. So 10x equal to 9.99 etc. Respective equations we mark a and b. Subtract the equation b from a. Subtract the equation a from b. Then 10x equal to 9.99 etc. and x equal to 0.99 etc. What is the subtraction result? We will get a 9x equal to 9 or x equal to 9 by 9, that is equal to 1 only. Now 1 means it is in the p by q form only, so we can write that which is in the p by q form. So I'll get right here x equal to 1, which is in p by q form. Now the question is asked that are you surprised by the answer? Discuss why the answer make any sense with your teacher and the classmates. B. While seeing at a just mere looking only, we can say that 0.9999 and when x equal to 1 we are taking, both are not having no gap only, almost it is very close to each other, so hence they are equal. So by mere checking, what we can say that we can say, since the question is asked, so we can say that we are surprised by the answer because 0.999 etc. is equal to 1, isn't it? So we'll write that yes, we are surprised Now what is the reason for this one? Because we can write that there is no gap between, in reality there is no gap between 1 and 0.999 etc. right? Or else what we can say, when you are doing the estimating run or round off cases, what you will do like this, 0.999 if it is coming, we will almost write the answer equal to 1 only. So this is the why the it is sense means 0.99 etc. goes on there continuously, it is going on, and on number line if you consider these numbers 0.99 etc. and the 1, the almost there is no gap, so the values are equal. Question number 5. What can the maximum number of digits in the recurring block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. We need to find how many number of digits are recurring in the block of 1 by 17. So we have to do the normal division to find out this one. It's a long procedure only. You can check the divisions by your own, and my suggestion is that when the denominator is 1 by 17, so we are expecting that less than one digit, that is 16, we are expecting, it's not necessary that always we should get a 16 number of digits can be repeated in a block. Just I'll show the division procedure for you. You can see that many number of digits are repeating there. So just to do and verify that whether you are getting like this also. I'll show the last step also. 1 by 17 equal to 0.0558822352941176647, etc. It goes on like this only. You can cross check this one, and the number is the remainder we are getting as a 1. Again it is going to repeat like that only. Maybe you cross check, verify that one, do the revision properly by yourself. Now what we want to say that when we are doing the 17 as a denominator, we are expecting that the 16 digits blocks may be repeated. By doing the divisions, you are coming to know that it is happening here. And what is the next step? I can do with one more example, that is 1 by 7. When you are doing the 1 by 7, what is the answer we got there? 0.142857. See how many number of digits blocks are repeated there. 6 digits blocks are repeated. So there is another case also where we are expecting this way, similar way. So here 1 by 17 is asked, so we can say that 16 digits are repeating, and the same as case with the 1 by 7 also. But it is not necessary that always the same pattern only following. The maximum number of digits what we are expecting in this case, when the denominator, if it is given, you can choose a number less than 1 only. So we can see the answer once again, and here one correction is there. 5 is repeated only one time, right? So this is not there. 0. I'll write once again, 0.05888235294117647. I can put a bar on that. Now count and see. 2, 4, 6, 8, 10, 12, 14, 16 digits are there. Here you see 2, 4, 6. That means 1 by 7 equal to 0.142857. This is another example, right? So the maximum number of digits which are repeating for this case is 16 number of digits, and here it is 6 number of digits, that is less than 1 the denominator. Now what type of the decimal expansion we are getting here? Non-terminating recurring one. Next question. Look at several examples of rational numbers in the form p by q, where q not equal to 0, where p and q are integers with non-common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? Let us take the example 5 by 2, 5 by 4, 2 by 5, 2 by 10, 5 by 16, which are the form p by q. And what we have to check means, what is the property of the denominator? What is the property of the denominator? So 5 by 2, when we are dividing, the answer is 2.5. 5 by 4, 1.25. 2 by 5, 0.4. 2 by 10, 0.2. 5 by 16, 0.3125. That means all these cases are examples for terminating decimals only. That a decimal expansion for these rational numbers, we are getting the terminating decimals. Now let us see that what type of the denominator, any property is there, any pattern can you see there when we are considering this type of the rational numbers. So 5 by 2, the denominator is 2, right? When we are taking 5 by 4, that means 5 by 4 is 5 by 2 square, right? 2 by 5, 5 only. Again 2 by 10 means 2 divided by 2 into 5. Next, 5 by 16 means it is 5 into 2 raised to 4. So when we are considering the denominator for these numbers, either 2 we are getting power of 2 or we are getting power of 5. Sometimes both we are getting. We already know that when we are having expressing as a 36 by 100. So 100 it is in the terms of 36 by 2 into 5 whole square only, that is 10 square, right? So there always the power of 10 is there. Power of 10 means the prime factors are 2 and 5 only. So when we are having this one, what is the conclusion we are getting means we can observe the denominators of the above rational numbers have the powers of 2, 5 or both. Therefore Q must satisfy in the form either 2 raised to m or 5 raised to n or both. So 2 raised to m into 5 raised to n, where m can take the whole numbers and n also can take the whole numbers only. So let us see that what is the meaning of both also. 5 by 2 we can write as 5 by 2 raised to 1 into 5 raised to 0. That means when you are having 2 alone, you can multiply with the 5 raised to 0. That means it is 1 only. So again we can express and bring into the terms of 2 into 5 format. So the power can take as whole numbers only. In the similar way, when we are having a single 5, that is 2 by 5 is there. So if I want to write a 2 by 5, that is 2 into 2 raised to 0 also I can write, there is no change in the result. So if it is a single 2 or single 5 is also present with any power, we can make into both the 2 and 5 while taking the power as 0. So what is the pattern we are getting means 2 raised to m into 5 raised to n for these type of the rational numbers whose decimal expansion is terminating 1. Now the powers can take the value whole numbers. This is the pattern we are getting. With this today's class I am winding up. Thank you.